So factoring trinomials. So here we have a trinomial of y squared plus 2y minus 35. So remember, factoring means that you need to have a product of something. Well, whenever you are factoring a trinomial, you're going to have a product of two things. Most likely it's going to be a binomial times a binomial. If you look up here, is there a GCF between all three of my terms? No, there isn't a GCF, so I can't factor out a GCF and call it a day. But what I can do is I can try to factor it. Now, I'm going to show you how I do it, and then I'll explain how guess and check also works. What I do is I kind of think about it as the rainbow method. I'll sometimes reference it as. That's just me making that up as a word. That's not a technical term, so don't go to college and say, oh, I learned the rainbow method for factoring. That's just the word I'm using because I like rainbows. So, if you look at your trinomial, what is your leading coefficient right now? Your leading coefficient is 1, right? So if you take that number 1 and multiply it by your constant, which is at the end, 1 times negative 35 is negative 35. Okay? Now I need to think about numbers or factors of negative 35. Well, what numbers multiply to get to negative 35? 7 and 5. Let's make one of them negatives. If I add these together, do I get my middle term? Almost. What really needs to happen, swap the negatives, so make it a positive 7 and a negative 5. Right? Okay. So because my leading coefficient is 1, I can go right to my factors. So that's going to be y plus 7, y minus 5. If I were to FOIL this, or just double distribute, y times y is y squared, y times negative 5 is negative 5y, 7y gets you to 2y, 7 times negative 5 gets you to negative 35. And then we are done. Okay? The long version is you do it by factoring by grouping. Now just watch this. Don't put this in your notes. Does everybody already have this written down and I can erase it? Okay, so technically what is happening, the reason why we can go right to that is due to factoring by grouping, which you guys did last lesson. Isn't it true that I can convert my 2y into 7y minus 5y if I work backwards? Isn't 7y minus 5y 2y? So not changing the problem, just changing the way it looks by expanding 2y into an expression of 7y minus 5y. If I bring down my y squared and my minus 35, now notice I have 4 terms. In your homework, when you had 4 terms, we grouped them by the first 2 and the last 2 terms. What's the GCF of the first 2 terms? Y. If I factor out a y, then I'm left with y plus 7. What's the GCF of the last 2 terms?
Negative 5.
Negative 5, which gets me to y plus 7. So what's the GCF of the first and the last? Y plus 7. What's left over?
Y minus 5.
Y minus 5. But it's a lot less work to just get to this and then go bam, right? Okay. So when your leading coefficient is 1, you can go right from this to this. I want to show you this process because when we get to it without a leading coefficient of 1, factoring by grouping is going to have to work there. Okay, so let's look at this one. We've got r squared plus 8r plus 12. Again, my leading coefficient is a 1. So we can do 1 times 12. So 1 times 12 is 12. What are factors of 12 that add up to 8? 6 and 2. So 6 times 2 is 12. 6 plus 2 is 8. So what are my 2 binomials going to be? R plus 6 and R plus 2.
That is factored.
That is factored. Done. You can check your work by multiplying everything through. R times R is R squared. 6R and 2R makes 8R. 6 times 2 is 12. So there's our answer. Okay. All right. Next one. M squared plus 6m plus 7. So my leading coefficient is 1. 1 times 7 is 7. Do we have any factors of 7 that add to 6? 7 plus 1 is 8. If this would have been a minus 7, then I could have turned one of these into a negative, right? And that would have gotten me to 6. But 7 plus 1 is not 6, it's 8. So what do we say? Not factorable. Because 1 plus 7 is not 6.
I see it now. I see it now.
If it would have been an 8m in the middle, then we would have been okay. If it would have been a minus 7, then we would have been okay. Not the case. All right. P squared plus 6ap minus 16a squared. Is there a GCF between all three terms?
No.
Nope. Okay. So now just treat this like we've been doing with the rest. Yes, I understand there's more than one variable in here, but just kind of ignore those for now. So 1 times negative 16 is negative 16. What are factors of negative 16 that are going to get us to 6?
Negative 2 and positive 8.
Negative 2 and positive 8. I like that. Right, because negative 2 and 8 gets us to 6. So if you just ignore the a for right now, if this would be a p minus 2, kind of leave some space there, and a p plus 8, leave a little bit of space behind it. But I need to get an a involved. My last term needs to multiply to a negative 16a squared. So what do I need to add to my negative 2 and my 8? An a. Good. Okay. And that'll get you your APs for the middle. So if you've got more than one variable, look to see what's in the beginning, look to see what's at the end, and put the P in the front, put the A in the back. If this was X and Y, then I would put an X here and put a Y here at the end. Questions with that? All right. So now we've got 16y to the third minus 32y squared minus 48y. Do you have a GCF? What is it? 16 and a y. So if I factor out a 16y, what's going to be left over? I have a y minus 2y squared, or y, right? Y squared, thank you. Y squared minus 2y minus 3. Can I factor the trinomial that's left over in here? 1 times negative 3 is negative 3. Do we have factors of...
Positive 1 and a negative 3.
Positive 1 and a negative 3 will get us to negative 2. Good. So that's going to go to y plus 1, y minus 3. Make sure you bring down that 16y in the front. Okay. So if we think we have a handle on it, when our leading coefficient is 1, make sure you're always looking to see if there is a GCF that you can factor out. If there isn't, then go right to it. If there is, factor it out and then see if you can factor what's left over. All right, so now let's get to a leading coefficient other than 1. So 12r squared minus 5r minus 2. Now, I want you to see how it's done by factored by grouping, and then I'm going to show you the shortcut so that you can utilize the shortcut. So it makes life nice and easy. So if we use this same method, 12 times negative 2. So you always take your leading coefficient times your last. Just in the other problems, it was always 1, so it was always the constant. But here in this case, it's 12 times negative 2, which is negative 24. Don't make it negative 2, because right away you're starting off with a wrong start. Now think about...
Negative 8 and positive 5.
Perfect. Negative 8 and positive 3, right?
3.
So negative 8 plus 3 gets us to negative 5. Now, this is incorrect. Don't put this in your notes. Then what students will do, they'll be like, oh, I'll just do r minus 8, r plus 3. Well, does that make any sense? Does r times r get you to 12r squared? No. That's not a correct answer. It's not that easy. So don't do that. Unfortunate, yes. But I will show you how you can make it easy. But before we can show you the easy part, you need to appreciate it. So I need to show you the hard part. So if we think about that factoring by grouping that I showed you before, I can convert my negative 5r into 2 different terms, which is negative 8r plus 3r. Right? That's true. Negative 8r plus 3r gets you to negative 5r. Okay. Now I bring down my 12r squared, and I bring down my minus 2. Now I have 4 terms. So now my brain should be saying factor by grouping, factor by grouping, factor by grouping. My first 2 terms have what GCF? 4 and an r. So that gets me to 3r minus 2. What do you notice about the last 2? It is 3r minus 2, so our GCF that we're going to take out is a 1, because I don't have to change anything there. So the binomial that's in common is what? 3r minus 2. What's left over when you factor that out? 4r plus 1. There's your answer. Could you have gotten there by guess and check? Yes. I hate guess and check because sometimes you're guessing and checking forever for it to work out. So that gets you there. Now, you're welcome to do it this way. Do the long method, make your branches, factor by grouping, gets you there every time. If this is not the same as this, then you know that these are not correct. So that's your first clue that something's not right. Your binomials should be in common. All right, so now, can I show you the shortcut? I have no explanation to why it works this way. I've tried many of times to prove why it works. I can't figure it out. It just works. Trust me on it. So if we go back to this step right here, negative 8 and 3. Now are you all ready? So this is the trick. What you do is you turn these into a fraction, and the number that goes in the denominator is going to be your leading coefficient. In this case, our leading coefficient is what number? 12. So I'm going to put 12 in my denominator of my fractions. Now I'm going to reduce my fractions if I can. In this case I can. Negative 8 over 12 reduces to what?
2/3. Negative 2/3.
Negative 2/3. And 3 over 12 reduces to 1/4. Okay. Now, the number that is in your denominator is going to end up being your coefficient of your, I'm going to use x term, but it's always whatever the variable is. So your first term, whether it's a, whether it's r in this case, your x term. And then your numerator is going to be your second term. So if I work on the first fraction, start on the bottom. This is going to be the coefficient in front of our r, so I'm going to get 3r, now work your way to the top, minus 2. Wasn't that one of the binomials that we had before? Go over to the next term. My bottom number is 4, so that's going to be the coefficient in front of my r. And it's a positive 1, so plus 1. Isn't that what we got when we did our factor by grouping? Yeah, it is. And again, always check your work. 3r times 4r gets you to 12r squared. Negative 2 and 1 gets you to negative 2. A negative 8r and a positive 3r gets you to negative 5r. Okay? We were technically doing this if our coefficient was 1, like when we had, I don't know, x squared plus 3x plus 2. I don't think that was one of our problems. Our factors of 2 are 1 and 2, which add to 3. Technically, what we're doing is we are putting this over 1 and getting 1x, or 1x plus 1, 1x plus 2, which is the same thing. It's just that your coefficient's 1, so you don't write it. All right, so let's try another one like that. So 3x squared plus 7x plus 2. We're going to go right to the shortcut method. So, do your rainbow. 3 times 2 is 6. What are factors of 6 that get you to 7? 6 and 1. What is my leading coefficient? 3. So I'm going to turn those into fractions and put 3 in my denominator. Don't forget to reduce your fractions. Can I reduce any of those?
One of them can be turned into...
Yeah, so that goes to 2 over 1, or just 2, and the 1/3 stays a 1/3. So if I just have a 2, that binomial is going to be x plus 2, because technically it is 1x plus 2. What's the 1/3 going to look like as a binomial? 3x plus 1.
That is a lot easier.
So your x's get attached to your denominator. Isn't that beautiful? But you got to remember to put in your leading coefficient here, and you got to remember to reduce those fractions, which are all easy things to do. And then put it in order. Again, always, always, always check your work to make sure that what you did was correct. Okay? All right. So let's try another one. Sorry, did you get that, Jamin? If you wanted to do it by factoring by grouping, it would be 3x squared plus 6x plus 1x plus 2. GCF, the first 2 is a 3x, which gets you to x plus 2. GCF, the second, is 1, which gets you to x plus 2. So x plus 2 times 3x plus 1 gets you there also. This is a little bit easier, right? All right, so let's try it again. 18m squared minus 19mx minus 12x squared. All right, so I'm seeing some giant numbers. So what I would first ask myself is there a GCF that I can take out to make my number smaller? In this case, there isn't, so that's a bummer. But that's okay. We've got calculators that will make our life easier. So 18 times a negative 12 is negative 216. Factors of negative 216. So what I would do is I would start going to my calculator. Negative 216 divided by 2 is negative 108 and 2. Does that add up to 19? Nope. 216 divided by 3. So negative 72 and 3. Does that get me to negative 19? No. Divided by 4. 4 and 54. Is that going to get me there? No, probably got to get higher. So 216 divided by 9 is 9 and 24. Does that get us there? No. Okay, so 216 divided by 6. 6 and 36. Is that going to get us there? No. 216 divided by 8. 8 and 27. Does that get us there?
Yes.
All right. Yay, found it. Okay, so 8, which one's going to be the negative between 8 and 27? 27, because it's a negative 19, right? Okay, so let's make our fractions. What am I going to put those over? 18, good. 8 over 18 reduces to 2 ninths. No, we're taking out what? 2, so 4 over 9. Is that what you said? 4 ninths. Just didn't hear you right. Negative 27 over 18. We can take out 9, right? So we get negative 3/2. Okay, so now notice I've got two variables. What's going to be the variable attached to my denominator? M. What's going to be the variable attached to my numerator? X. Good. So now let's just turn these into the binomial. So what's the first one going to go into?
9m plus 4.
9m plus 4x.
4x.
Yeah. And then 2m minus 3x. Done. Okay. Questions with that process? All right. If this problem had a negative in front of it, so can I erase stuff? Okay. If this would have been negative 18m squared plus 9mx plus 12x squared, whenever you have, that's a really bad looking 2. Whenever you have a negative as your leading coefficient, it is always wisest. I mean, you could end up factoring it and keeping it there, but it's always wise to factor out that -1 first to get to the 18m squared minus 19mx minus 12x squared. And then you would factor what's left over. So what was our answer for that one again? It was what? 9m plus 4x and 2m minus 3x. So then you would factor as normal, but then you would have to remember to bring down the -1. So maybe you should make a quick note in your notes. If the leading coefficient is negative, factor out a -1 before factoring, or before the rainbow method, whatever you want to call it. And then just remember to keep it in there as you go. All right, I've got one more type of example I got to show you yet to step up our game. Do you think you have a handle on this, the shortcut method? Okay, and what's nice is it works every time, so you just need to remember to put it over your leading coefficient and reduce your fractions. All right, so the last thing we need to cover is factoring by substitution. So the last two examples, or the last two problems in your homework are going to be similar to these types, 47 and 49. So you might not have seen this in your Algebra 2 class. So we have 2 times x plus 3 squared plus 5 times x plus 3 minus 12. Now when you do factoring by substitution, now technically what we could do is I can multiply all this stuff out, and I would end up with a simplified trinomial, and then I could factor that. But that's a lot of work that I don't need to do. So what we like to do is it sometimes is called U substitution, because U is a variable that's not used very often in any textbook or in any math class, so we use U because it's unique. So if you were to, let's say, let U equal x plus 3. It doesn't have to be U. You can use whatever. If you're preferential to a different letter in the alphabet, go for it. But I'm going to be using U. So that's going to turn my polynomial into the following. 2u squared plus 5u minus 12. That looks a lot simpler, doesn't it? Yeah, can we factor that? Let's do the rainbow method. So 2 times -12 is -24. What are factors of -24 that get us to 5? It's going to be 8 and 3. Which one's the negative? 3 is going to be the negative. Shortcut method, what's my leading coefficient? 2, so put it over 2. Can I reduce? Yeah, 8 over 2 reduces to 4 over 1, so then I have negative 3 over 2. So what are my two binomials going to be? Well, it's not x, it's going to be u plus 4 and 2u minus 3. Okay, but now I'm not done because I need to substitute in my x plus 3 back into my u's. So instead of u, it should be x plus 3 plus 4. Well, is that easy to simplify? Sure. That goes to what, x plus 7. So there's my one binomial with the x in place. This one's going to be a little bit trickier because I'm going to have to distribute. So 2 times x plus 3 minus 3. Distributing gets me 2x plus 6 minus 3. So I would get 2x plus 3. So that's my final answer there. The only challenge here is if I were to multiply it back out, it's not going to get me to directly this. If I were to multiply all this out, then they would end up being the same. But that's your u substitution. All right, one more. That's not a binomial that we're letting u stand for. Okay, so don't stop here. Some students will stop here and will circle this u plus 4 times 2u minus 3 and say that's their answer. It's not your answer. You have to then substitute back in. So you're doing two substitutions. First with the original substitution, then back to get it to where it is. All right, so last one. Sometimes what you'll see, so I think this is similar to what you'll be seeing in number 49, is an exponent higher than 2. So here I have 6y to the 4th plus 7y squared minus 20. Okay. You can do your u substitution here, but to be honest, it's probably easier just to factor it like you normally factor it. But I'll show you what it would be like with the u substitution. So if we let u equal y squared, and the reason why I'm letting u equal y squared is because isn't it true that y squared times y squared is y to the 4th? Yeah. So this turns into 6u squared plus 7u minus 20. Now let's factor like normal. So 6 times negative 20 is negative 120. Oh goodness, calculator in hand. Factors that are going to get me to 7, 5 and 24, no, 8 and 15, does that get me 7? Yes, okay, so 8 and 15, which one's the negative? 8, good. Put it over 6, simplify. So negative 4/3, and what are we doing here? Taking out a 3, so 5 over 2. So that gets me to 3u minus 4, 2u, don't do that, plus 5. We're not done. What's going to go in place of my u? Y squared. So 3y squared minus 4, 2y squared plus 5. If this would have been an exponent of 6 and an exponent of 3, so it was 6y to the 6th plus 7y to the 3rd minus 20. Then I would have let u equal y to the 3rd. The trick is you're always going to let u equal whatever this is right here, y to the 3rd. If it was 8 and 4, then I would have let u equal y to the 4th. If it was 10 and 5, then I would have let y equal y to the 5th, or let u equal y to the 5th. Okay? All right, so work on those homework problems. Come in with questions.